The headline on the other major news story today, to which we intend to devote some time, is very simple. Hello, Dolly.
In February of 1997, a Finn Dorset sheep named Dolly sent waves of future shock around the world.
The first living, breathing clone of an adult mammal.
It's possible we're seeing a scientific explosion comparable to the atom bomb or the moon rocket or DNA itself.
For many, it was a case of science gone too far.
Are we acting more like the creator than creatures? Are we trying to play the role of God in all this?
Predictions multiplied about just what this breakthrough would bring.
Soon it will be possible to give her thousands of absolutely identical sisters.
Animals could be cloned with human diseases and new therapies tested on them.
Endangered species can take heart.
This is not an elaborate, sophisticated technique. It means that any decent college or graduate school student could potentially clone a human being.
Whatever became of Dolly, and all that speculation about the brave new world she ushered in.
Cloning is the process of replicating genetic material from a pre-existing organism through the insertion of foreign DNA into a vector, which then grows to become the desired organism. There are three types of cloning: therapeutic, gene, and reproductive cloning. Therapeutic cloning is the creation of organic matter to treat diseases. Gene cloning is the insertion of DNA into a cell for the purpose of replicating a specific gene in that DNA sequence. Reproductive cloning is the extraction of a cell from a pre-existing organism, inserting that cell into the egg of a surrogate mother, and then recreating an entire individual identical to the original organism. Genetically modifying organisms dates back to when man discovered that they did not need to hunt to survive, but could grow their own sustenance. The process began with people picking plants that produced tastier or larger fruit, and then reproducing that specific plant to be able to continuously receive the desired qualities. One such example is corn. Corn started out as a wild grass called teosinte that Central Americans over 7,000 years ago bred until the grass became a species that did not grow independently in nature, thus becoming one of man's first genetically engineered food sources. While produce has been reproduced for centuries, it wasn't until recently that entire organisms have been able to be created, such as Dolly the sheep. Dolly was produced from a cell injected into an unfertilized egg that was then birthed from a surrogate mother. The major breakthrough with Dolly was the possibility of implementing special proteins in their milk that would be able to treat diseases such as cystic fibrosis as well as other medicines.
Research into cloning should continue due to its ability to provide a sustainable food source and revolutionize the pharmaceutical industry.
Most soybean crops today are genetically modified, and soy derivatives appear in hundreds of food products. So you're probably serving genetically modified soy to your whole family, your dog, as well as your kids. See, baby food formulas commonly contain soy.
Estimates suggest that as much as 80% of U.S. processed foods may contain an ingredient from a genetically engineered crop, such as cornstarch, high fructose corn syrup, corn oil, canola oil, soybean oil, soy flour, soy lecithin, or cottonseed oil. All genetically modified foods are regulated heavily by the FDA and must undergo multiple tests and studies in order for that product to be released on shelves. For produce, genetically modified foods need to meet the same requirements as traditionally bred plants, and among the only released genetically modified produce is a papaya that is resistant to a ring spot virus, which are currently being grown in Hawaii. An increase of genetically modified foods in the world market would make available cheap, affordable sustenance to underdeveloped countries, as well as providing those countries with means of growing any type of food in their specific landscape. Medicine has been derived from bacteria and yeast for the past decades, and such a process has allowed for many pharmaceuticals, such as insulin, but these molecules only deliver an antibiotic that lacks the complexity of mammalian cells. To recreate such intricate proteins, other methods must be pursued to achieve the desired drugs. Altering the genetic code of the proteins within mammalian fluids, such as cow's milk or blood, allows the desired complex proteins to be specifically engineered to fight diseases in humans. The cow's ability to produce about 10,000 liters of milk each year naturally causes the cost of manufacturing to drop drastically. The lack of machines to produce the medicines allows for prices of said pharmaceuticals to be made affordable to those in poverty or in underdeveloped countries and allow them to overcome any illness.